Alright, let's calculate a coefficient of drag for a flat plate, for a streamline, and for a bluff body. So here we go. We have a flat plate represented as this, as a streamline. The free stream velocity is 22 meters per second. The free stream density is 1.201 kilograms per meter cubed. And then the force of drag that's seen, that's going to be pushing against it, so the force of drag in this direction on the plate, 0.052 newtons. In actuality, let's say that this is going to be a flat plate attached to another surface. So again, we only have the air blowing over the top. These are not going to be in this particular case. So let's say if you had a table and you had a plate sitting on top of the table, the air is blowing over top, just at this top surface. Alright, how do we go through and make our calculation? Well, the coefficient of drag is the force of drag over 1/2 rho v squared a. We can simply just put our numbers in. 0.052 divided by 1/2, the density is 1.201, the velocity squared is 22 meters per second, and the area, again, 2 meters by 2 meters, remembering from our first set of lectures the size of a meter, is going to be 4 meters squared, and putting that all in there, the coefficient of drag is seen to be 4.5 times 10 to the negative fifth. Very, very small number. Let's do another calculation where now we're going to have to calculate the coefficient of drag due to a bluff body. Same set of conditions, but now we just take the plate and flip it up. So a bluff body, given the same conditions, but the force of drag, again on this case we have a represented force of drag equal to 101 newtons. So we can calculate our coefficient of drag again is force of drag over 1/2 rho v squared a. In this case we put 101 in, 1/2, 1.201, 22, and the area again is 4 meters squared. Putting that into our calculation, we get a coefficient of drag of 0.087, significantly larger than when we have streamlined. Okay, that concludes our lesson on the force of drag and coefficient of drag.